Welcome to the illusion where seeing is not believing. Have you ever looked at something and questioned your own eyes? You're not alone. Optical illusions, those mind-bending tricks of perception, have fascinated people for centuries. From ancient Greece to modern art, illusions reveal the fascinating gap between what we see and what our brains understand. These visual puzzles aren't just for fun, though. They offer valuable insights into how our brains process information, shaping our understanding of the world around us. So buckle up as we journey into the fascinating world of optical illusions, where reality itself seems to bend and twist before our very eyes. Get ready to be amazed. Decoding illusions, when our eyes play tricks. So, what exactly are optical illusions? They are fascinating phenomena that challenge our perception and understanding of reality. In simple terms, they're visual images that trick our brains into perceiving something that isn't really there or is different from reality. These illusions can be found in everyday life, art, and even nature. Our brains are constantly trying to make sense of the world by interpreting the information our eyes send them. This process involves complex neural pathways and cognitive functions working together seamlessly, but sometimes these interpretations can be delightfully misleading. Optical illusions take advantage of the brain's shortcuts and assumptions, creating a fascinating disconnect between what we see and what is actually there. Imagine looking at a magician seemingly pulling a rabbit out of a hat. The trick is so well executed that it leaves you in awe, questioning the reality of what you just witnessed. You know it's a trick, but the illusion is so convincing that it leaves you wondering, how did they do that? Optical illusions work similarly. They play with our expectations and perceptions, making us see things that defy logic. They exploit the shortcuts and assumptions our brains make, leading to a captivating disconnect between perception and reality. By studying these illusions, scientists and artists alike gain insights into the workings of the human mind and the nature of visual perception. So, next time you encounter an optical illusion, take a moment to appreciate the intricate dance between your eyes and brain and the marvel of human perception. The Müller-Lyer illusion lines that mess with your mind. Let's dive into a classic example, the Müller-Lyer illusion. This optical illusion has been baffling people for over a century. Take a look at the two lines. At first glance, they might seem different in length. They're the same length, right? Wrong. Despite what your eyes are telling you, both lines are actually identical in length. The line with the outward pointing arrows appears longer, even though they're identical. How does this happen? It's all about perception. One theory suggests that our brains interpret the arrows as depth cues. This means our brain is trying to make sense of the 2D image by adding a 3D perspective. The outward pointing arrows might resemble the corners of a room, making the line seem farther away and therefore longer. This is because our brain associates these shapes with depth and distance. Conversely, the inward pointing arrows might resemble the corner of a building seen from close up, making the line seem shorter. This is another example of how context influences perception. Our brains are constantly trying to apply real-world context to what we see, and sometimes that leads to these fascinating misinterpretations. Optical illusions like the Müller-Lyer illusion reveal just how complex and intriguing our visual processing system is. So next time you see an optical illusion, remember it's not just a trick, it's a window into the incredible workings of your mind. The Ames Room, where size is an illusion. Now let's step into the Ames Room, a mind-bending space where size itself becomes an illusion. This room is a fascinating example of how our perception can be easily tricked by altering the environment around us. This specially constructed room is trapezoidal, with a sloping floor and ceiling. Unlike a typical rectangular room, the Ames Room is designed to distort our sense of depth and size. When viewed from a specific angle, it creates the illusion that people standing at different depths in the room are dramatically different in size. This effect is so convincing that it can make a person appear to grow or shrink as they move from one side of the room to the other. The Ames Room plays with our brain's assumption that rooms are rectangular. By manipulating the shape and angles of the room, it challenges our brain's expectations and creates a powerful optical illusion. Our brains struggle to process the distorted depth cues, leading us to perceive the person on the shorter side of the room as much smaller than the person on the longer side. This discrepancy occurs because our brains are wired to interpret visual information based on certain assumptions about the world around us. This illusion highlights how our brains rely on context and prior knowledge to make sense of visual information. Even when that information is deliberately manipulated, the Ames Room serves as a powerful reminder of the complexities of human perception and the ease with which our senses can be deceived. It's a testament to the fascinating ways in which our minds work to interpret the world around us.